good morning, good afternoon, good evening, wherever you are, or whether you're joining in the live session or maybe catching up on the recording later on. So threat modeling. Again, this definition you probably would find in Adam Shostak's books and elsewhere as well. It's defined as structured and repeatable process to identify threats and plan to mitigate them against valuable assets in a system. So that valuable assets could mean servers, applications, systems, databases, data, whatever you call it. So you all know what the most valuable asset in an enterprise is data. And of course, everything around that data, whether you call it servers or applications or databases, systems, so on, networks, so on and so forth. Why threat modeling, right? It's like similar to data modeling. You need to understand how the data is organized using, and as part of that, they came up with data modeling, which is a very, very old concept. So threat modeling is a relatively new term as part of the security, design and architecture stuff, which is supposed to be done at the beginning of the creation of a system or building a system. But in practice, I've seen that that enterprises or teams go back and threat model a system after it's been built, because that's a legacy system, which is okay as long as you follow the same process. We cannot build and maintain secure system. We cannot build secure system and cannot maintain secure without understanding the potential threats and what could be, whether our systems are vulnerable to those threats, and understanding the risks coming out of those combination of threats and vulnerabilities. And hence, threat modeling helps to identify and mitigate the threats. So we all might be doing in security analysts or solution architects or anybody who is building a system might be thinking of those in a random way or in an unstructured way in the brain, or on the whiteboarding stuff or on a paper, right? But what threat modeling means is a structured and repeatable process. No matter who does it in your team, it should have the same outcome or similar outcomes, so that one person can submit their threat model to another person who could understand the same thing, whether they're applicable from the perspective of applicable threats or from understanding the overall risk perspective. Threat modeling is used generally to model a system, come up with an architecture diagram, or scope out a system, identify the potential threats, analyze if your system or application or whatever you call it, right? We keep using these words interchangeably today, whether the system is vulnerable to those threats and what are we going to do about it. Threat modeling is part of the risk assessment. Threat modeling term probably is not directly there in the NIST cybersecurity framework, which is what we're going to use today to identify the controls to mitigate the risks or for risk mitigation. It is part of the overarching risk assessment an organization or enterprise performs, which is basically, this is the definition from CSF, cybersecurity framework. So the alignment of threat modeling maps to IDRA 3. Threats, both internal and external, are identified and documented. Okay, so it is part of the CSF, but it doesn't clearly say threat modeling. It is somehow you identify the threats and mitigate them. So threat modeling is different from threat intelligence. It's not the same. Threat intelligence is another term that is used mainly in the operations side of security, whereas threat modeling is used on the architecture side or design side of the SDL. Both involve identifying threats and mitigating them, mitigating risks cropping from those threats, but those both are two different things performed by two different teams for very different purposes. Threat modeling is done before you build the system ideally, and threat intelligence is an ongoing operational thing. Both map into the same risk assessment category of NIST cybersecurity framework, which is IDRA 3. Okay, so you guys, I think 80% of who answered the survey at the beginning mentioned you guys already use Stride. So I'm going to assume that most of you are aware of Stride, but for the sake of completion of this presentation, I'm just going to go through the definitions or on a very high level, because we'll be using this threat modeling classification heavily for the next 1.5 hour plus. So STRIDE stands for spoofing, tampering, repudiation, information disclosure, denial of service, elevation of privilege. Spoofing is impersonating someone or something, whether it's impersonating a human user or an API client or a system user or a server. Tampering is modifying code or data to compromise the integrity of a system. Repudiation is doing something but claiming to have not performed an action, whether someone is walking into a lab, high secure lab, and breaking something and walk away and nobody catches it and claim that they didn't do it, or compromising a system, being a bad actor or a hacker to breach a system and leaving no proof of they did it. Information disclosure is straightforward, exposing information to someone not authorized to access it, whether it is internal users or external users, doesn't matter. Just because you are an employee of an enterprise doesn't mean that that employee should have access to all the sensitive data within their enterprise. Denial of service is all these map into CIA, confidentiality, integrity, availability. Denial of service. Sometimes it could be a bad guy incorporating an attack to compromise the system or bring down the system, or sometimes it is self-inflicted denial of service. If honest employees make mistakes, they could be restarting a server without proper change management, for example, or deploying bad code which could compromise the stability of the system. Elevation of privilege is gaining capabilities without proper authorization, allowing a regular user having access to administrative capabilities or privileges is an example of an elevation of privilege. Okay, so this is the famous 4-step process of threat modeling, 4-question framework by Adam Shostak. There's a book. If you obviously most of you probably are already aware of it. So there are 4 things, right? What are we doing as part of threat? So threat modeling has 4 line items. Understanding what are we building? Is it a HRMS system or a CRM system or an internal infrastructure, whatever that is, building a platform for applications teams to deploy their applications on their platform, or designing a network or integration between 2 sides, whatever it is. What is that we are building, right? And to understand the scope of what we're building, come up with an architecture diagram to scope it out, what exactly we're building, whether it is infrastructure or a platform or an application, and think about what can go wrong. We probably all do this, right? But it is probably we do it in an unstructured way or non-repeatable way, right? It's all in the brain, or sometimes the whiteboarding exercise, they erase it after the exercise. You cannot go back to it, or you cannot get that reviewed by someone else. So what can go wrong? Identify the model or the architecture diagram or the system that we're building to identify potential threats. Okay, once you know what could go wrong, now next question is, what are we going to do about it? So indicate which threats are already mitigated, because it's not always we are building from scratch. We might be building an application on top of a platform, which is probably built on top of another infrastructure, which is all blessed and taken care of certain aspects of risks, right? For example, in a cloud supply chain, if you're building an application on an infrastructure service environment, some of the data center issues or networking issues or switches, security configuration of the network components or devices is already taken care of by the cloud provider. So which threats are already mitigated and which are our responsibility or not yet mitigated and could identify as potential gaps, and what are we going to do about it? So document those risk mitigations and then validate that with other experts, by peer review or someone who does this for a living, or someone who are trained enough to validate and review these threat models. So those are the 4 question framework. What are we working on, or what are we building? Create an architecture diagram as step 1. Think about what can go wrong, what could go wrong, and analyze the model to identify the potential threats, and what are the potential there could be known vulnerabilities. There could be something which you need to discover the vulnerabilities against those threats and understand the potential risks. And then what are we going to do about it? What are the risks that we could avoid? What are the risks you could mitigate? What are the risks you are going to accept them? Document it, and then validate the threat model against this system by an expert reviewer or a peer reviewer, whoever it is that needs to review to validate that did we do a good job at all. As we said, it's a threat modeling is defined as a structured and repeatable process. So as part of this whole STRIDE framework, as part of this threat modeling exercise, these are the 4 threat actors that are threat modeling elements that we are going to use to identify or decompose an architecture diagram of a model so that we can perform the exercise of threat modeling repeatedly or structurally. So there are 4 types of threat modeling elements that we'll be using today. Actors are typically humans, a customer or an admin or a regular user or a partner or an employee, or it could be a system user, a batch job user, an API client, API user. The data stores is the next type of threat modeling element, which are basically anything which stores data, databases, file system, in memory or on the disk. Okay, anything which stores the data we call that as a data store here from the threat modeling elements perspective. And the next element is data flow, anything which flows between component to component in that architecture diagram on whatever the networking protocol is, IPsec, HTTP, TCP, IP, whatever, right? So any data flow which flows from one component of an architecture diagram to another one. If you identify a component which is not either an actor or not a data store or a data flow, then it is a process that runs typically code, and those are the ones which are like web application, web servers or app servers, or any even the OS process. Depending on your the scope of the threat model, it could be anything other. If anything is a process, if it's not an actor, if it's not a data store, and it's not a data flow. Okay, so since this is a basic threat modeling, we'll just focus on very high level, like web applications and databases, data stores. That at that level, we don't really go into the level of threat modeling at the OS level. Okay, so this is something, it's a matrix, STRIDE applicability to these threat modeling elements. That means there are 6 threat classifications, STRIDE, and there are 4 threat modeling elements: actor, process, data store, data flow, right? We could have probably deleted the last line, but this is what, so it's a matrix. The first 4 lines, this is what you need to focus on. And throughout our exercise, and I do this even now, I keep that as one on close by or on a different screen or monitor to make sure that which threats apply to which threat modeling element. So in this case, for example, spoofing and repudiation apply to an actor or a human user, for example, or a non-human user. All the 6 threats apply to the process, right? And based on the other 2 lines, basically 3 of them apply to data flow and 4 of them apply to data store. I keep that as always on one of the screens to identify which, when I'm looking at a component or architectural component of an architecture diagram, what could go wrong, right? I always think about, okay, what are the components and what are the applicable threats for that particular component. So in the spreadsheet that I'm going to show, that's already mapped for you. So that basically this is already mapped, so it is easier for you guys to just worry about the last element, which is what could go wrong, what are we going to do about it. Okay, so what is cloud threat modeling? Cloud threat modeling is basically threat modeling with the understanding of which threats are already mitigated by a cloud provider based on the service model or deployment model. So there are like 3 service models: software service, all of you know that, platform as service, infrastructure service, and deployment models: public, private, community, hybrid, right? So we're not going to obviously deep into the deployment models today. We're just going to focus on the 3 service models: SaaS, PaaS, and IaaS, and understand the shared responsibility matrix. Based on this, we're going to perform the threat modeling today. Yeah. So we don't, if it's a SaaS application like Workday or Salesforce application, there are so many SaaS applications out there that we use. Every enterprise uses hundreds of SaaS applications nowadays. Most of the time, we rely on the vendor risk assessments and the security certifications of that cloud provider that they're going to provide, the SOC 2 type 2 or something like that, or our own vendor risk assessment processes, and rely on those and not worry about whether the data is encrypted as part of our threat model. Okay, so whether the cloud provider performs all the security implement all the security controls or not, that would be a third-party vendor risk assessment process. And we just are going to rely on the third-party vendor risk assessment process. And every company probably has different ways to assess their vendors or third parties. But as part of the threat model, it's going to be a black box for us. So as we move from SaaS to PaaS to IaaS, there's more risks or more responsibilities that stay with the cloud consumer, and hence your threat model will be more complicated, relatively speaking. So a threat model for a SaaS application will be less complicated, relatively speaking, compared to PaaS, which is relatively less complicated than IaaS, which is relatively less complicated than an on-premise system, where you have full control and there's no shared responsibility. Every server, the whole network, every database and every system, an organization is responsible to secure that system. Anyway, the data traverses through. Any questions on the shared responsibility? This is widely published shared responsibility model, without going into a lot of details. Like every cloud provider has published their own shared responsibility model. For example, Azure has got its own shared responsibility model metrics, but this is it's a cloud provider agnostic, on a very high level. You cannot outsource security, governance, risk, and compliance. So infrastructure security, cloud provider takes care of it. For SaaS and PaaS, for the platform security, the cloud provider takes depending on what kind. For SaaS, platform security is also taken care of by the cloud provider. Okay, so with that, I'm going to share the spreadsheet template, which I'm going to use to demo how to build a threat model for on-premise application, SaaS, PaaS, and IaaS, before we break for 10 minutes, and then you guys come back and choose which service model you want a threat model, and we go from there. Okay. So,
all right, I think there's a question in the chat. Not sure if we want to address this first or later. But Navi asked, how is platform security different from infrastructure security?
Yeah, I'll answer that by taking an example. So assuming that you are aware of a force.com platform, which is from Salesforce. Force.com platform itself is deployed at AWS infrastructure service provider, right? So a cloud consumer of force.com do not need to worry about OS level controls, operating system level controls, whether it is RHEL VM or Windows VM or at the OS level vulnerabilities or risks. The cloud consumer don't need to worry about it. That is managed by the cloud provider, in this case, force.com. So force.com platform service provider apply the OS patches and take care of the OS configuration, secure configuration at the OS level. That's just one example. So the ACLs, the firewall rules from one web server to app server to app server to database, it's all taken care of by the cloud, by the platform provider. But if you're consumer infrastructure service, then you need to worry about the security groups, you need to worry about the security OS level controls and security configuration, SC Linux and all that stuff. So infrastructure as an example is AWS, right? Platform provider, platform service provider example is Force.com. And the same company, Salesforce, provides a SaaS service as well, which is a different service than Force.com platform. And that's where the cloud consumer have less control and less responsibilities to secure the data. Okay, cool. Okay, so this is the template which I created based on my work at Red Hat. Of course, it has been modified a little bit for this exercise as well, so that we can perform a lab, hands-on lab for the participants. And this template will be shared after I complete the demo. Okay, so what does it has? It has just the first tab has introduction. What is threat modeling? The same thing that we talked about, right? And what is the process? It's a 4-question framework. What are we working on? What can go wrong? And what are we going to do about it? And then get it reviewed by an expert or some peer reviews, right? So it just explains the 6 steps here. And the next, the lookup values here, spreadsheet tab, worksheet, all it has is the 6 threat classifications: spoofing, tampering, stride, because we are going to use stride, spoofing, tampering, so on and so forth. 4 threat modeling elements: actor, data store, process, and flow. And the column C is what you can customize, right? Obviously, I'm using here the NIST CSF 100+ controls. Basically, I'm populated all of them. And at Red Hat, within our organization, we use our own standard called Enterprise Security Standard, which has like 35 security controls. You could obviously, this is where you customize if you are using, if you have your own security standard or own policy or whatever you call it, the controls that you have. Some companies have 100 controls. This could be expanded to CCM, Cloud Controls Matrix, which has a lot more than 100 controls, right? So this is nothing but a copy and paste from NIST CSF, which I'm assuming that you guys are familiar with it. This is 1.1. So I'm just going to share the screen of NIST CSF here, just for the sake of completeness, although the assumption is you are already familiar with it. There are 5 categories of NIST CSF: identify, protect, detect, respond, and recover, right? So there are about 100+ controls here with the function, category, and subcategory. So what you see here in this template, or the Google Sheet template that I'm sharing on the left-hand side, which is relevant NIST CSF controls, or copy from the C column here in this Excel sheet that I'm sharing. Okay. Now, for the demo purpose, I created 4 architecture diagrams. Very, very simplest architecture diagram you can think of, right? And then I'm going to walk through how to use this spreadsheet to threat model for each of these 4 types of architectures. Okay, so the first one is a simple 2-tier web application, which customer or partner or employee or whoever it is, the users, human users, are accessing an internet-facing web application. So we're going to assume that web server and app server is the same as one component here for the scoping perspective. And then there is a database. So this is an on-premise application. This is not a cloud application. So that means we have full control on it. So as I said, there are 6 steps, right? So the first 2 steps are analyzing the model. Step 3 and 4 is identifying the threats. Basically, first 2 is what are we building, right? And C and D is what could go wrong, and E, F, G, H here is what are we going to do about it. I'm going to just check what should be the artifacts we'll be creating as part of the threat model. Okay, So question from Vishal is, in a mature team, what should be the artifacts we will be creating as part of the threat model? I guess the question is spreadsheets. Is that the question? So the question, if you have a matured threat modeling team or exercise, I've seen people, mature organization, using different kinds of tools, commercially available tools. Erase Risk is one of them, and there are many other commercially available tools. I've seen mature threat modeling teams not using any commercially available tools, and they do it manually, which is a Word document of 25 pages. This is somewhere in the middle. This is for the basic beginners, right? Beginning to intermediate team. I don't know whether we can call it as a mature organization, but I've seen over the years that many teams with complicated architectures with 25 components in an architecture diagram, using the spreadsheet, figuring out or identifying the vulnerabilities as part of the exercise, which they never thought of before, and implementing those controls or plan to implement those controls to mitigate the risks. So if that, I don't know if that answers the question. If not, bring it up again, and then we can go with that. Okay. Yeah. Okay. So let me focus on this diagram for now. So what I did is it's a sample diagram, right? I numbered them, the labeled with some numbers, so that it's easy to identify these components in the next spreadsheet or worksheet here. Okay, 1 is an actor, 2 is the data flow, 3 is a process, 4 is the data flow, 5 is the data store. So all the 4 threat modeling elements are used here. An actor, there are 2 data flows. One is between a user browser to the application, web application. The other data flow is between web application to the database. And 3 is a process, number 3, and number 5 is a data store. So remember the matrix, the threat modeling matrix, where there are 6 on horizontally and 4 threat modeling elements. That is pre-built into this spreadsheet, so that you don't need to go back to that matrix all the time. But what you need to do is, okay, you think about what is the artifact depicted in the architecture diagram. So the first diagram I'll go slow, because after that it's a repetition, right? Doesn't matter how complex the diagram evolves into. They all fall into these 4 threat modeling elements, whether it's an actor or a data store or a data flow or a process, and it's a repetition of it and in a structured way. So if you remember the matrix, for an actor, there are 2 types of threats that are applicable: spoofing and repudiation. Okay, the spoofing and repudiation. And I just used some free text English in English to describe the threat, right? Which is optional, right? So the main thing is, what is the threat modeling element, which is an actor, and the next one is, what are the applicable threats? So for each type of threat modeling element, this spreadsheet repeats all the applicable threats and try to facilitate what are the potential risk mitigations that can be implemented. And these controls are being pulled from the niche CSF that I showed you a minute back from here. Okay, so for spoofing, what is the risk mitigation? You can, I will be asking questions like this. You may answer them on the chat, so that we have this an interactive session. If a user, the potential threat is spoofing of a user, what are the potential risk mitigations, or what are the potential controls? It's there in one of the slides, which is an authentication, right? User authentication. You can extend that to say strong authentication, or 2-factor authentication, or multi-factor authentication, right? So what is the relevant control? So here I already called out that implemented or plan to implement strong authentication, right? This could be, any English text, you can type it here, MFA or password authentication or some authentication, strong other. You can type it whatever you want. You can update it later or customize it however you want. It's up, makes sense to you guys. But this one is basically I selected PR access 4, protect access management number 7, which is users are authenticated. Okay, so I looked at that sub part of the text and I selected that as the risk mitigation, right, from the CSF. If I'm using a different framework, like for example, if I'm using Red Hat on standard, we call it as enterprise authentication, which implies that it's a 2-factor authentication. Okay, and there are so that we have like 3 columns. That means you can put 3 controls. You don't need to have all the 3 controls for every risk for every threat. And again, there is a many-to-many relationship between threats and mitigations. That means one threat may need multiple mitigations or multiple controls to mitigate the risk. One control might mitigate multiple threats or multiple risk items. So the next one, I'm moving on to the next one, repudiation, right? So a user could delete an object in a web application or update an object or whatever, a line item or whatever you call it, delete another user, for example, if you're an admin user, and claim have not performed that action or not deleted that or not updated it. So in general, what is the risk mitigation for that? Logging, okay, making and protect those logs. That's the control. You log every event of interest. When a user is created, a user logged in, the user deleted an object or whatever it is, and keep those logs for a certain period of time so that you can go back and analyze who performed what. So from the NIST CSF perspective, the control, I selected 2 controls. One is PRPT, which is protect. So and the description says audit log records are determined, documented, implemented, and reviewed in accordance with the policy. Okay. And the next control, I use 2 controls for this. You don't need to, right? The second one is event data are collected and correlated from multiple sources and sensors. So first one is logging. The second one is monitoring. This comes under detect category or function of NIST CSF. And let's say if you don't like any of the NIST CSF controls for that particular line item, you can type free text in this column, log all events of interest and migrate the logs to enterprise log collection and analyzing platform, for example, Splunk. You don't have to necessarily select from the NIST CSF. But if you select from NIST CSF, no matter who looks at it, they all understand exactly which control is being used to mitigate the risk. So I see one question: how repudiation different from tampering? I'm confused. What exactly is repudiation? So repudiation is performing any action and claiming that they have not done it, as simple as walking into a sensitive lab or high security lab and walking out without doing anything, right? Or reading some confidential data, viewing it, right? Not doing anything. Just you're not supposed to read someone else's salary, right? But there's no way to prove that you perform that action. That's repudiation is but nothing but allowing users or allowing actions to be performed, and there's no evidence to prove that someone did that action. Tampering is basically compromising the integrity of a system. So when the data is flowing from one server to another server, and if that is going across an unencrypted channel or a connection, so you could modify the network packet, for example, if it is no protection, no network security. I think the easiest way to explain tampering from my perspective is SQL injection. Okay, so let's say, assuming that you understand what SQL injection is, or generally in a web application vulnerability injection is, you can modify few elements in the URL, get URL, and you could probably, inject code or inject data or even perform some actions to perform tampering, right? But if the application is logging each actions, so it is protected from repudiation because it is logging, but it's not stopping you from tampering the code. Okay, I'm reading Anil's question. Is that threat modeling, threats, mitigation process, and compliance audit performing is same? Okay. Okay, so I will generalize this question. Is threat modeling and mitigation is same as compliance auditing? It is not the same. Audit is different. Audit is after you build the system, and the third party is coming in to audit and make sure that all the controls are in place. They need evidence, right? So threat modeling is before you build the system, the architects, the design, the people who, as part of the design, high-level design, the lead, solution architects or developers or whoever you call it, basically they think about what could go wrong before you even build the system. Audit is after the system is built and have been in use for years. So threat modeling is risk assessment and mitigation. Okay, so we shall try to answer Anil's question. If that is not answered, please let me know. So I'm moving on, okay, to the next component in the diagram. Okay, you might have forgotten the diagram going here. So the next component is number 2 here, data flow between actor and the web application. So there are three threads that are applicable for a data flow, which is tampering, information disclosure, and denial of service. Okay, so as I said before, one security control can mitigate multiple threats. One threat may need multiple security controls. So there's a many-to-many relationship between threats and the security controls to mitigate those risks. For both line number 5 and 6, which is information tampering while in the data flow and information disclosure in the data flow, it can be mitigated with the same control called PRDS2, protect data security. Number 2, which is data in transit, is protected. If you have SSL or TLS, whatever, SSL probably is not the right word anymore. So if you have TLS 1.2 connection or IPsec, an encrypted tunnel or encrypted connection, you can mitigate 2 threads with data flow tampering and data tampering in the data flow and information disclosure in the data flow. Okay, you can always type something else here in free text. I can't think of any other security control from CSF which is more direct than this one, which clearly says data in transit is protected. That's enough. That one control is enough to mitigate these 2 threads. And the next one is denial of service of a data flow. That means the data flow is not available, or it's subjected to the threat is denial of service. So the description is an attacker could launch distributed denial of service or just DOS to degrade the availability of a web application to users, and the free form text explanation on how to mitigate the threat is implemented. I plan to implement firewalls at appropriate levels or security groups in case of AWS or whatever the terminology is, basically to have network level security and configuration at the network level, right? So this is an internet facing application that we're talking about. So from this NIST CSF perspective, I selected 3 controls here, which is PR, protect access, network integrity is protected, that is network segmentation, right? And segregation. So that means you have a web server in the internet facing and app server in the DMZ, and there's ACLs between them. So there is no direct connections coming, and there is only the connections are coming on a valid port and valid protocol. Everything else is closed and those kind of things. And the next one is, again, this is also relevant to that. So PRPT, I think protective technology under the protection category. Communication and control networks are protected, right? And then the network is monitored to detect potential cyber security events. So I selected 3 controls, right? You don't need to be 3 if it doesn't make sense to you. So obviously, most of the enterprises, of course, they keep monitoring their networks. That's the DE, detect category, comes in here. So we finished 2 threat modeling elements, actor and data flow. Now we are moving to the third category or threat modeling element called process. As you may recall, from the architecture diagram, the application that we talked, our web application, is the process, and every threat applies to it. All the 6 STRID applies to it. So by now, you basically, you should probably understand, okay, information disclosure, is basically encryption of data in transit or at rest. But in here, it's a process, right? It's not necessarily data flow, so the encryption of data in transit doesn't apply. But let's see what applies here. Okay. So spoofing. Here it's not user spoofing, it's the application spoofing or the website spoofing, like CNN.com or redhat.com. How are we going to mitigate the risk of someone posting or hosting a fake redhat.com? So in general is a web secure certificate, SSL cert, TLS certs. But in the NIST CSF, there is no exact control which talks about the PKI or the security certificates, secure certificate management, which is what we call it internally. So I selected the identify governance. That means governance and risk management processes at the cybersecurity risks control. That's the most relevant that I could think of that maps to that an organization have a process in place to manage the certificates and renew those certificates, whether it's 3 months or 2 years or whatever it is, procure a certificate from a certificate authority like DigiCert or subs, certs, whatever it is, right? And manage them properly as to mitigate the risk of an attacker launching a fake or spoof website to mislead the users. So the tampering, this is where the WASP web application vulnerability comes into picture. A web application is vulnerable to all the top 10 WASP vulnerabilities and more, right? I'm sure most of you are familiar with the WASP top 10. One of them is injection and cross-site scripting vulnerabilities. So, and the example which I already explained about when there was a question about tampering. So an attacker could launch a SQL injection or parameter injection and can compromise and tamper the application or the compromise the integrity of an application. So the mitigation is secure development, static application, secure testing, pen testing. So I selected 3 controls from the NIST CSF that vulnerability scans are performed. That is under the detect category. Secure system development lifecycle is secure system lifecycle is implemented. That is IP under the protect category, and then all the identified vulnerabilities are mitigated or documented as acceptable risks. Okay, so repudiation doesn't matter what component it is, whether it is data flow or data process or data store. Whenever you see repudiation, it's all about log monitoring. The control is all about logging and monitoring, logging events of interest and monitor those logs. So I won't spend much time. It is basically audit the logs from PRPT1 and event data are collected and analyzed. Information disclosure. It's not a data flow, right? So it is again secure system development to manage the systems is implemented. That is web application development. Again, you could launch SQL injection to both tamper the data, whereas and as well as breach the data. You could, if that application is only displaying the data, right, or letting the users to display the data, you could still inject or perform SQL injection to read data that belongs to someone else. So you're not tampering, but you're viewing. So information disclosure happens. So the development and testing lifecycle management must be in place, and also selected PRDS7 that the development and testing environments should be separate from the production environment, because an employee or a contractor who is not supposed to have access to the production data If the non-prod and prod environments are not separated, a developer may access the production environment or production. If the production data is copied to a non-prod environment, they have access to production data, which results in potential breach of data breach, right? Anything which is disclosed to unauthorized person is a data breach. And moving on to the web application denial of service. So here it is how it's of the application itself, right, of the server itself, whether it is we call it web server, app server, or application itself. The controls are basically from the CSF. There is IDBE. ID stands for identify, BE stands for business environment. Resiliency requirements to support the critical services are established for all operating states. I selected that one. Whereas also mechanisms under the product category for load balancing and failover, whatever you call it nowadays, right? Resiliency, available to support availability and resiliency, which could be used interchangeably sometimes, and also adequate capacity to ensure availability is maintained. So throttling to make sure that if there are million requests coming directly to an application at the same time, you throttle the request in such a way that it doesn't let that high traffic brings down the server. The last one is elevation of privilege, which is basically explaining a regular user might accidentally or intentionally access some unauthorized data or perform administrative privileges, right? So the mitigation is authorization, strong authorization, enforcement of principle of least privilege. So that would be PR access 4. That means access permissions and authorization are managed, incorporating the principles of least privilege and separation of duties, SOD. Okay, so application is the one which has all the 6 threads that are applicable to it, and hence these are the potential risk mitigations that I suggested. You don't need to be. You can have your own risk mitigation based on whatever framework you are using. Now moving, data flow is a repetition here, right? So if you go back to the diagram, now you're talking about this data flow. We talked about this data flow in depth. So I'm going to skip that, right? It's nothing but data flow now from the application to the database server. So the controls are same. Data in transit is protected to mitigate tampering and information disclosure. And it's similar to the server denial of service, except that here you need to configure the database and not the web server or app server environment. And of course, the network needs to be monitored, and communication systems or networks are protected, and network integrity is protected. And now moving to the database, which is a class threat modeling element called data store. And only four threats are applicable to that. That is tampering, repudiation, information disclosure, and denial of service. So for the tampering of the database itself, I selected PRIP1, right, which is baseline configuration of information technology systems is created and maintained, incorporating security principles, concept of least functionality, which is nothing but database hardening of a database, whether it's Oracle database or SQL Server, whatever the database, LDAP, anything is hardened in such a way that only certain ports and protocols are open, and make sure that all the security principles are incorporated at the database level. Okay, repudiation, again, as I said, doesn't matter which component threat modeling element we are talking about. Whenever there is repudiation, you're basically the control is logging and monitoring. So it's the same 2 controls are always selected that. For the information disclosure, here it is not a data flow, it's a data store. So that's why data at rest is protected. Okay, so that itself is enough to say that, okay, if you implement data at rest is protected, you're basically mitigating the risk of information disclosure in a data store. Denial of service, whether it's a database or an application server or a middleware server or whatever, right? It's the same controls. Resiliency requirements to support a critical system are established, and load balancing and failover is implemented, whether you call it active or active passive or active passive or DR, whatever it is, you basically implement those controls. And to map it to the CSF, I selected the same thing that you always seen, adequate capacity to ensure availability is maintained. So make sure that only certain number of database connections are open at a time. and have a limit on number of connections to allow so that the database don't go down or unavailable to the authorized users or authorized connections. I spend more time on the first one because after that it's all repetition. Once you understand the threat, the applicable threats to a threat modeling element, the risk mitigations are exactly the same. It's just a repetition and in a structured way. So now it's a SaaS service. You don't have access to the database level. You don't have access to the application code. You're not developing an application or deploying code. Basically, it's a SaaS service. Here, the first two elements are exactly the same. That means actor is subject to spoofing. You must have strong authentication, right? Sometimes it is federated authentication. That means if you're using a SaaS service, it is configured to use your own IDP if in a single sign-on manner, right? So that your business users enjoy the same kind of authentication and single sign-on no matter which SaaS service they're using in an enterprise. Or sometimes, if you're a small organization, you don't have that kind of infrastructure. You're relying on the cloud providers authentication, right? Most of the cloud, of course, all the cloud providers or SaaS applications have their own authentication mechanism. It's not preferred for a large enterprise because they don't want to replicate the same users and user credentials across hundreds of SaaS services. So that's why these two controls, that is, so within identify category, you have the supply chain management subcategory where the suppliers and third parties are reviewed and assessed before you sign a contract. The first one is reviewable, and the second one is the signing contracts. For the data flow, it's exactly the same. Data in transit is protected, right, for both tampering and information disclosure. And then the denial of service, you don't have any control at the network level for a SaaS application. You're purely relying on the third-party risk assessment or risk management or whatever you call it, VRA process or VRM process, risk management. So basically, I selected the suppliers or selected or perform risk from the risk perspective, risk assessment perspective, and then the contracts are in place. So now, whatever was that web application, now that is our SaaS service here, right? In this case, a SaaS service, it's a process, right? So now, for a SaaS service, whether it's Salesforce.com or ServiceNow, you don't have control to deploy the certificates unless it's a single tenant environment. In a multi-tenant environment, the cloud provider manages the SSL certs or whatever TLS certs. So you're basically mostly relying on these two controls called IDSC2, Identify and Supply Chain Security or Supply Chain Management, to perform the assessment and to sign the contracts. It's basically contract-based mitigation. And of course, again, there are so many types of SaaS services. Some are small, some are big, and so many types of cloud consumers, so many types of contracts, single tenant, multi-tenant model. Some cloud providers allow you to perform pen testing on them. Some cloud providers don't allow you to perform pen testing on them. They provide you a third-party pen testing environment, certificate that they have done it or they do it regularly. So here, this is optional, newly identified. If you have that control to perform threat modeling, pen testing on them, you basically ask the vendor to fix them, right? You cannot fix them because you don't have control on their code development. You don't want to. It's a SaaS service you're talking about. And sometimes you want those logs to be migrated into your Splunk instance. Sometimes the cloud provider don't allow to migrate the application logs because it's a multi-tenant environment and has other cloud consumer logs as well. So it's basically, you can see the theme is all about IDSC and for most of the SaaS service. Hopefully that was useful. Hopefully that was helpful for you guys to start basic threat modeling using a spreadsheet in a structured and repeatable way, right? So some of the architecture diagrams could be very complex. Yeah. So look at this. This one has 21 components, right? There are users, and then there is a SaaS application. There are multiple instances. There are multiple data flows. It's a hybrid cloud architecture. And if you see the threat model, you have like 54 lines, And the controls here are the Red Hat controls that I was talking about, not the niche CSF. There are only 30 controls here. And the red here means we plan to implement it. It's not done yet. That's what it means by that. And once it is done, you know, they're supposed to go back and remove the red flag here. So depending on how complex the architecture is, it might take a while to complete the threat model. But it is, at the end of the day, it is structured and repeatable, right? It is just a repetition. Once you understand how to threat model those 4 elements, actors, data flows, data store, and process, most of the time it's the same controls that apply to them. But in certain cases, you implement in a different way. Right? If it is an internal system, you select a different control. If it's an internet facing web server, you implement a different control.